I am actually going to ask for your help with something. All right. I just got this email during the break from Jeremy Sutton, who runs the Wentzville site. Jeff, I am participating in a panel this Friday where the topic will be exploring technology-based careers. One of the areas the moderator would like to focus on is coding. She would like for the panelists to be able to answer the following questions. What knowledge, skills, and awareness do students need to be successful in a programming coding career pathway? Could you help me by providing a response to this question? So what I'm going to do is, before we take our next break, I'm going to ask you to give me some ideas. Because, I mean, I can answer it, but I'd rather have people who are doing it answer it and see if the stuff I'd come up with is the same stuff you'd come up with. All right? All right. We're up to page 145, and we're going to talk about nested ifs. I'm going to go through an example. If it sounds familiar, it's probably the same example I went through for JavaScript last semester. So we're going to assume for a second that we're going to have a party, all right? And it won't be on school grounds because there will be alcohol at the party. So in order for you to be able to come to the party, both of these conditions must be true. You must be a Rankin Technical College IT student. It doesn't matter if you're here or St. Louis, and you must be greater than or equal to 21 years of age. All right? So if Amin says, well, I'm 20, well, then you can't go. Get the idea? All right. So what we're going to do is just keep it simple, is we're going to make a variable that's going to be called IT student. All right? And this will be a variable called age. All right. So I'm going to say here, bool IT student. And we'll just set it, we'll assume it's true. And we're going to say int age, and we're going to set that equal to 21. All right, so I can now say if IT student, and again, if that's confusing, we'll just say equal true. Okay, we can say that, that's fine. And age greater than or equal to 21. Right line, you may go to the party. Else, well, it's tough. You may not go to the party. Now, looking at what I've got written there, and I'm asking you this, and please be honest. Whoops. Does that make sense? All right. Now, if it turns out, okay, if it turns out that for whatever reason, you know, I ask for RSVPs and Ethan takes a little pity on me and says, yeah, I'll come. But he's the only one who gets back to me. Well, that's not going to be a very good party. All right. No offense to him, but, you know, with just two people, it's not really a party. Okay? So I come back here and I change this to an or. All right? Now that means that anyone that's over 21 or any IT student can come to the party. Does that make sense? Only one of those criteria has to be met. So the only people who cannot come to the party now are non-IT students who are 20 years of age or less. Does that make sense? All right. Now, you just said that makes sense, and that's good. But I want to grab all of this. I want to put it back to what we had there before. And I'm going to grab every bit of this. I'm going to copy it to the clipboard. I'm going to move this down. I'm going to reproduce it. Why are you doing that? Hopefully you'll see why in just a second. There's my little delimiter there. And I'm going to put it all in again. All right? Now, I could also take this and I could write it like this. What we have here, this is called a nested if. It's an if within an if. Does it make sense to you? The only way I get to that if that's right there, the only way I get to this if that you see in blue is if the first if is true. Does that make sense? So I'm showing you two different ways that we can write the same thing. Some people like to use nested if conditions, an if within an if. And you can nest anything. You can have an if within an if, you can have an else within an else, except you can have all sorts of stuff. Weird combinations. You can nest a loop within a loop, all sorts of different stuff. All right? But I want you to understand that the only way we even get to this is if that's true to begin with. Now, if we put an else in here, of course, we could say right now, we could do a right line. Only IT students at this party. And I'm purposely doing it like this because I'm trying to use virtually a non-computer example, something that people could just identify with. All right? So some people will take a situation and write it like this. Some people will take it and write it like this. We're doing the same thing both ways, but it's which one makes more sense to you. So a nested if is an if within an if, which I think is on the test. All right, we're going to go over all that stuff in just a bit. So when they talk about nested if, that's what they're going to show you. It's an if within an if. All right. So the first if has to be true, or you don't get into the second if type of an idea. All right. Like I said, some of her examples in here I just thought were, let's just say they bordered on being a little bizarre. All right. So the else, you know that if you add an else to an if the if is not true, you do the else. Does all that make sense? Again, going back to the example I just showed you. Let's go back to the original one. If you meet both criteria, you can go. If you meet neither criteria, or if you only meet one criteria, you can't go. The key thing to understanding an if-else like this is if the condition is true, you do what follows and you skip the else. If the condition is false, you skip the body and you do what follows the else. And if you get that, there's no more to get. That's it. All right? Because a lot of times people tend to make this more difficult than it actually is. All right? The big difference is when, if I asked Amin a question, he comes in this morning and let's just say Rankin's got some new shirt. It's a really odd color. And I say, hey, Amin, you like this color shirt? And he doesn't really want to offend me. He's like, I don't know. Okay? Which would be a natural type of thing. Computers can't do that because computers are Boolean animals. 0 for false, 1 for true. So again, true, do this. Not true, do this. If it's true, do this and you skip all this. If this is false, you skip this and you do all this. And if you get that, then you understand how to use an if with an else. All right? So again, she's got some more examples. She always does stuff like, should we wear a coat and other stuff like this. And then she puts examples in here. These aren't bad, but the examples that she usually gives in here, they just are goofy. All right? But again, if you're confused, this one's a good program. The one that's on 152 in the book. Okay? She has you enter 3 numbers. And then she compares and sees if all 3 are the same, or if the first and second are the same, or if the first and the third are the same, or if the second and third are the same, or if none of them are the same. And she does all that with ifs. That's actually a pretty good example. So if you're confused, I'd suggest that you take a look at the example that's in here. Because she runs it too. She explains everything she's doing and then runs it and shows all the different types of possibilities. These are what are called truth tables. That's a truth table for an and statement, which says if both conditions, remember what these are called from the test? I shouldn't say that because you can take it again. But those are operands, right? All right. So if X is true and Y is true, the whole thing is true. Otherwise, if either one or both are false, the whole thing is false. That's a truth table, all right, for an and operator. So they both have to be true. I mentioned the short circuit evaluation before, how if you're doing an and the first part's false, you don't even check the second part. If you're doing an or and the first part's true, you don't check the second part. That's the short circuit evaluation that they're mentioning right there. All right, there's a truth table for an or. So with an or, it's always true unless both conditions are false. You can make some really god-awful, god-ugly conditions. This and this, or this and this and this, etc. You can do that. But I want you to understand that if I've got multiple conditions, I always do the nots first, then I do the ands, then I do the ors. That's the order that you do all these. And think about why that's the case. All right? This, the not, that is what's unary. Went over that the other day. Okay? This is as relaxed, for lack of better words, as possible. So let's say that I've got a bunch of conditions in an if statement. I'm not going to write one out, but let's just say I do. Let's say that I want to do the and before I do the not. Or let's say I want to be even better, I want to do the or before the and. What overrides all this? What? Parentheses. But if you've got a combination of not and or, and you're not using any parentheses, or just parentheses around the ends, you do all the nots first, then you do the ands, then you do the ors. That's the order of precedence for these operators. They do mention here that you can also use this if you use just a single ampersand or just a single pipe sign. The reason that people typically use that is then it doesn't use the short circuit evaluation. It tests both sides no matter what. All right? I will tell you that for that, you hardly ever use the single and or the single or, unless you're doing things like writing an operating system, or you're writing system code. For us, we'll never have to use this. I'm not saying it's not, or it is on your test. We'll look at that in just a bit, all right? But you'll, as an application programmer, I've never had to use that in my life. All right, again, you can combine ands and ors and nots, etc. Already mentioned that, so you get stuff that looks like this. And you can get some really god-awful looking conditions. You know, that's the old joke, and I'm not trying to be funny here. The computer always knows whatever it is you're trying to do, even if you don't. Since it's literal, it's always going to do what you tell it to do. So if you don't put parens in when you should, well, I meant it to do this. Well, this computer doesn't know you meant it to do that. Then you do an example that goes through and or logic on 150, 151, okay? Then we get into the switch. And I like the way she shows this, maybe even better than the way I did it. Oops, sorry. What she's saying here is, if we're assuming you're at a 4-year institution, if your year is 1, you're a freshman. If it's 2, you're a sophomore. If it's 3, you're a junior. If it's 4, you're a senior. Otherwise, invalid. All right, maybe, you know, or they could have written something else. Maybe you're an audit student or whatever. It doesn't matter. All right. Now, you don't see it written like this. You always have the else and the if right on the same line. No one ever writes it like that, but you can. All right. But another way that you could write that is like this. Now, you can make your own determination as to whether or not that's cleaner. All right. To some people, they look at, oh, that makes a lot more sense. But again, and I showed you this before with the example we went through, it's switch followed by, in parentheses, whatever it is you're switching on, this value right here, that value. These things that were after the case must be, so the 1, 2, 3, 4 must be the same type as that. Must be. You don't have any choice. Program's going to break. So if this was a string and I was checking 1, 2, 3, 4, it wouldn't even work. I'd get an error message. But if it was a string, I could check for double quote 1, double quote, something like that, if I wanted to. All right? So it's case, okay? And then when you do a bunch of stuff, whenever you're done, you put the word break in there. The only thing that you, just so you know this, and I like the way she wrote this, it's not mandatory that you put a break after a default because there's nothing that comes after it anyway. See that? There's no word for it to fall down to. The default, if you use it, must be last. If you don't put it last, I think you get an error message. All right? Now, what if what we wanted to write here, what if we wanted to say, if you were a freshman or a sophomore, you're an underclassman. If you were a junior or a senior, you're an upperclassman. Does that make sense? All right. Then we'd say switch year, and we can say case 1, colon, case 2, colon. Now we can say right line, underclass, break, case 3, case 4, right line, upper class. Break. I'm not even going to put a default in because I don't want to put it in. You get what I'm saying though? You can put multiple conditions. That's totally legit to do that. So if it's this one or it's this one, you can do that. That's totally fine. Some people even put them on the same line. I don't think in this language, I think if you put that on the same line there, it's going to give you an error. I might be wrong, but I've never tried it. All right?
Is that something you put after this first set of code like this?
You could, yeah, you could do another one, do it afterwards, sure, if you wanted to do both. In that case, you would be writing freshman, and then you'd be writing underclass, etc. Yeah, you could do that. When I was a programmer at AT&T Bell Labs, almost everything they did was in switch statements. The problem was, after a while, and I'm not making this up, some of these switch statements were 10, 20, 30 pages long because people kept adding more conditions and more conditions and more conditions and more conditions. Now, does this make sense? I'm using the, probably they did it like this because it's a numeric order, right? Make sense? Let's assume that you're going to a college, and I'm making these numbers up, but freshmen are, let's say, 13%. Sophomores, for whatever reason, are 33%. All right? Juniors and seniors, 46? That would be both like 27%. Okay? Do you understand what I'm saying here? Then, that should be the first thing in here. That should be the first case. So you should say case 2. Even though it's not in numeric order, who cares? The thing that's most likely to happen should be first, whether that's an if or whether it's a switch. Then, these two, since they're the same, those should be the next two, and this one, since it's the least, that should be the last one. I'm giving it, writing a lot of lines and making it look ugly. Does it make sense though? It's just the same kind of thing that let's assume that I've got to talk to a bunch of different people, and they want me to do it and reach as many people as possible. All right? So let's say I was going into a high school like this, and it turned out that these were the numbers. I'd probably go in and talk to the sophomores first, Then I would either do the juniors and seniors or the seniors and juniors, but I'd do the freshmen last. And you have to understand that, because people get so ingrained in their mentality, I gotta do it in this order, 1, 2, 3, 4. So what? Who cares? All right. The other thing that you could do, and this wasn't what you asked, Brady, but what you might want to do up here is you might have even wanted, instead of doing this, we could have set up constants. We could have had a constant called freshman that was equal to 1, etc., that kind of thing. So then it would have been case freshman, then we could have done that. That would have made a little more sense there. But, one thing that I think this author has written a good book, but sometimes I think what she doesn't do is she doesn't explain things like what I just told you. And if you listen to that, you thought, well, that just made sense. I don't know why you even spent, yeah, maybe it didn't make sense to everyone in here. I don't know. All right. So I'm not trying to insult anybody's intelligence, but I'd rather go over something like that than assume you just know it. All right. I give an example here. This code is invalid. Why? Because again, there's no break. All right, we already talked about that. Again, where you can combine, oh, should have used that one, there you go, upper class. So there's a lot of different ways. They mentioned in here that you can come in, remember these enums? That's when you define your own variable. Oops. And now we've got accounting. Well, what does that do? That makes this a little bit more readable when you do that. Now, if you might disagree and say, no, it doesn't, then don't do it. All right, the conditional operator. I'm going to show you an example, and this is, believe it or not, this is going to be virtually the same example I showed you in the JavaScript class last semester. All right, but I'm going to show it again. The only difference is in JavaScript we didn't have ints where we have them now. I'm going to say int x num1 equal 37. Int num2 equals 63. Int max. Now you should all know this. I can write this. I can say if num1 greater than or equal to num2 max equals num1. Else max equal num2. Does that make sense to everyone? Doing something like that? All right. Well, what I want to show you, I'm just going to move it over here. I can replace all that with one line of code. So I can replace all of this with one line of code. How do I do that? I come through here and I say max equal, and then I say a condition. And if it's true, I say this. And if it's false, in fact, let me I'll put it on 2 lines.
What's the question mark for?
We're going to go over that right now. This is called a ternary operator. Remember we had a unary operator like -3 because it only had one operand. We had a binary operator, x plus y, because it had 2 operators. This is a ternary because it has 1, 2, 3 operands. All right, the question just got asked, well, what does that mean? After the question mark is what you do if the condition is true, and after the colon is what you do if the condition is false. This is sometimes called the ternary operator, and it's sometimes, literally in books, it's called the question mark colon operator. All right. After the question mark. So this says if it's true, do this. If it's false, do this. And that's why I put greater than or equal to, because what if they were the same number? What if these were both 37 and I had just said greater than here? It really wouldn't matter in this case. All right. And I'm going to ask this question. If the answer is no, it's fine. You don't even have to answer. But maybe some of you in here have got experience working with Microsoft Excel or some kind of a spreadsheet package. And if you've done any kind of more complex work with a spreadsheet package, you may have written macros. That's kind of what this is a macro. All right? And I want to say one more thing. I'm not going to give you an example because I don't want to confuse you. Because people say, well, what if you've got 3 conditions? All right, there's the true, there's the false. What you put after this, what you put after that one can be another question mark colon operator. You can nest these and make them, you can make some really god-awful looking statements that will work, but will probably confuse most people that are looking at them. All right? So I went to a conference years ago where they talked about this operator. And the guy who brought it up said, I got a question. He said, I spend time and I show the students this. Anybody use it? And most people said no. He said, let me tell you how, the only way that I use it. And he did something along the lines of this, so I'm going to rewrite this. But he said something along the lines of, so it said if your pages were 1, all right, then you would want to write page. Otherwise, you'd want to write pages. See what we're talking about? So if something was only 1 page long, the pages would be equal to 1, so you would write page. But if it was anything other than 1, you would do this. Now, that's not a bad example, but how many times is this going to be true? How many times? Once, right? How many times is this going to be true? If you've got an 800-page book, that's going to be true 799 times, correct? I would rewrite that like this. If it's not equal to 1, put pages, otherwise, put page. Does that make sense? You want to make life as easy as possible for the computer. By and large, whether it's something like we did last semester, whether it's a website, or you're writing an actual application program, the computer is not just there to serve you. Your computer might be, all right, but if you're writing application programs, it's not set up like that. All right? So anytime you can save a little bit of CPU time, you want to do it. Plus, what you're showing is that you understand things logically. And just because we're used to having a life where we go 1, 2, 3, 4, you are already breaking that rule because, remember, we're starting to count with 0. All right? So that's the conditional operator, so you've seen that. The not, again, is an inverter. So if I did this, go back to the examples that I've been showing you. I'll write another one here. Int x equal 23. It means nothing. So I say here, now if I say if not x, does it make sense to people that that's any number less than 23 or any number greater than 23? Does that make sense? Then you understand not. All right? And there's all sorts of different ways. So if I had some kind of a complex expression where I wrote if, I don't know, x is greater than or equal to 7 and, y is less than or equal to, or equal to 4, you could probably write that or part of it using a not. I had an instructor when I went through this stuff. He always said, there's 2 kinds of people. There's the kind of people who are going to write things that make sense, and there's the kind of people who are going to use inverters like this and put not and everything. He said they should have their own lane when they drive cars, and if you ever meet them on the street, you should walk on the other side of the street. That was the way he felt. But people have different mindsets. They have different things that make sense to them. And I can explain something, and you might hear what I'm telling you. Brady might hear it in one way. Evan might hear it another way. Valerie might hear it in another way. And it's whatever way makes the most sense to them. And that's how you should be writing your code right now, is for whatever way makes the most sense to you. All right, you've got plenty of time. that if you get hired into a company, that if they don't like the way you're doing something, they'll let you know. All right? Now, where that kind of stuff becomes really important is if you are working in a place that's, when I say something is real-time sensitive, do you understand what I'm saying? Again, give you an example. I go out to Ticketmaster.com, all right? And yeah, I want to see the tickets for Green Day, okay? Freaked my daughter out that I was karaokeing one night and I did a Green Day song. She's literally got up in front of all the people there and said, "You're too frickin' old to be singing something like that." But the people clap, so I thought they liked it. So you come in there, okay, I want to go here to the Hollywood Casino Amphitheater. So I come there. All right, see tickets. Well, I can grab that one or I can grab a different one. And actually, that shows you how old I am. My daughter actually contacted me and asked me if I wanted to go to that concert right there. Those are guys that I saw when I was your age. All right, so we come here and we do this. All right, find seats for me. See all seats. All right. So what's going to happen when we do this, if I say, please select seat map, all right, and I say that I want, I don't even know, okay, N was split or whatever, so I get these. What's going to happen sooner or later is it's going to ask me if I want to make a purchase. And if I say yes, then what it's going to do is it's basically going to take a picture of this. And for the next 45 to 90 seconds, no one else can go in there and buy those tickets, because someone else might buy the same tickets that I want. So I've got 45 to 90 seconds, whatever it is, to decide. And I can pick any tickets I want then. Then after that, it opens it up. Does that make sense? That's real-time sensitive. If you've got a program that's real-time sensitive, then you want to write code in the most expedient way possible. You want to write code where a lot of times, rather than saying if your flag equal true, you want to just say if flag, because that actually executes faster. You might be told, hey, Evan, we've got to cut the time on this off by 2 milliseconds, which is 0.002 of a second. All right? But that might be the difference between something working and not working. We're not to that point right now where you have to worry about stuff like that. All right. What's that?
How are they even clocking that?
Like what I just showed you, or what?
Like if somebody is mentioning.
Oh, what they do is they run the program and they hook it up to the system clock, and they have all sorts of operations they want to do, and they have there are people who are called system testers. That's what they do. All right, so common errors. If you're checking for equality, you all know this. Yeah, Brady, it's on the test. Double equals, equality, single equal assignment, you know that. Never put a semicolon at the end of an if, or a loop, or whatever, or a switch. Having several statements and not putting the curly braces around there. That's why I said always put in the curlies. All right? Putting an and statement in there and having this and then not putting a statement in after it. All right? Performing accurate checks, this is what I showed you before. That basically if you want an inclusive accurate check, this and this. So a grade that is greater than or equal to a 0 and is less than or equal to 100. That's an inclusive check. Grade less than 0 or grade greater than 100, that's an exclusive. So inclusive means you include it, exclusive means that way. So for exclusives, you use or, for inclusives, you use and. All right? It's probably more than the author put in, but just so you know that. So she goes through this, when to use one as opposed to the other. I mentioned that to you before. Now in GUI programs, it's still important, but it's not as important as in console programs. What you're going to see, and I'm going to show you this either in the next chapter or after that, is we can go back. If I went back and wrote that same program that I showed you before, the odds and evens, if I did it with a GUI, we could have it immediately handle it. So that with very, very easily, so that if we put in no input or non-numeric input, the program just wouldn't go any further. All right, we'll talk about that in future classes. There they mentioned runtime. I already mentioned it to you. think that's, yeah, good. All right, so let's do, if you've got your books with you, great. Let's do the review questions. All right. Bring them up here. That's good. We waited for you because we're doing the review questions. And I knew you'd want to be here because now that you have your book, I knew you'd want to start marking it up. All right. So these are the review questions for Chapter 4. All right. It says, what is the output of the following code segment? All right. And you go, if A equal B. They're not equal, but this is always going to be the output. Always. It might write black, white, but it's always going to write white because there's no curly braces there. But since these are not equal, since A and B are not equal, it's going to skip this and it's just going to write white. Does that make sense? If it doesn't, go back and take a look at it. You have to understand this stuff. Not so much for the written test, but for the hands-on. You will be asked questions where you're going to have to ask questions to the computer. So this is the time to ask if you have questions or start keying in some of those assignments yourselves, some of the stuff that's in the book if you're still confused. All right, so number 1 is B. Number 2, what is the output of this? A is less than B, right? Okay, so it's going to write both. Now we have the curlies. So it is black, white. Now, if they were equal or if A was greater than B, you'd write nothing. Even if you write that down, please look up on the screen here, number 2. If A was greater than B, so in other words, if A was 5 or if A was 4, it wouldn't be less than. Since we don't have an else here, we do nothing. So again, number 1 was B, number 2 is C. Number 3, what's the output of this one? Well, is A greater than B? No, it's not. So we'd skip that and we just print B, white. All right? So if this is starting to make sense to you, that's good. All right? And sometimes this is the best way to learn this stuff, is just put in a bunch of examples yourself and start looking at them. And if you're still confused, then write yourself little programs. Or go out to where I just showed you that, learncs.org, or .com or whatever, I guess it was learncs.com, and key some stuff in and look at it. Number 4, if the following code segment compiles correctly, what do you know about variable x? And it says here, x is a Boolean variable. Well, how do I know x must be a Boolean? What's in here must be a Boolean condition. This is a really bad question. I would disagree with that, but that's okay. Like I said, if I ever had her in here and I told her what I thought about some of her stuff, she'd probably say, when you write your book,
I have a question about three.
yes.
Because there's no curly braces, why do you why? Technically 4 is greater than 3.
No, A is not greater than B, though. That's what you're checking.
I was thinking opposite, sorry. I was thinking never mind.
All right. Number 5, what is the output of the following code segment? All right, is C greater than D? Since you put the semicolon on the end, everybody see that? I already told you that that's an error. See where the cursor's blinking? So regardless of whether it's true or not, it's always going to write green, yellow. Always. So don't put a semicolon at the end of an if statement. Because then it's not a Boolean condition anymore, it's an executable statement. All right. Number 6. Everybody has the first 5? Okay, number 6. What is the output of the following code segment? All right. If C is less than D, it is. If C is greater than 8, it's not. So it's going to write here yellow. You have to sometimes, that's what I just did, that's playing computer. Sometimes that's the only way for you to understand that, is for you to physically play computer. And I've had people that have really struggled to learn this stuff, who've turned into really good programmers. Sometimes they'll even pull out a piece of paper and write it out, whatever works for you. All right. Number 7, what is the following output of the following code segment? If E is less than F, so is 5 less than 10? Yes. And F less than 0. Well, that's not true, so it's going to write orange. Remember, it's an and for number 7, so they both must be true. Correct? All right. Number 8. What is the output of the following code segment? If E is less than F. All right. But now it's an or. So since E is less than F, since 5 is less than 10, it doesn't matter what the second check is. You're going to write red because of that short circuit evaluation that we talked about earlier. So number 8 is A, red. Number 9, which of the following expressions is equivalent to what's up above? All right. Since this must be true, before you can get in there, it must be an and. I would have, myself, there's nothing wrong with what the author did, but I would have put parens around this, and I would have put parens around this. So I would have had 2 extra sets of parens. That actually will make the program execute a little bit slower, but you're leaving no doubt as far as what you're looking for. All right? So number 9 is A. Number 10, have you noticed this is different than what we've had before because you're actually doing some work now? This isn't just wrote, oh yeah, that was on page 362 of the book. Yeah, it said this. Now they're asking you to actually think, and based on the results of different conditions and stuff. All right. Which of the following assigns true? Oh, that's just like a question from hell. If I ever saw anything like that on a test, I would just tell you the answer before you took the test. All right. Which of the following is equivalent to this? This just shows you that people write conditions in different ways. You know, let's just assume here, as an example, let's assume here that every one of you and me, we have 3 Rankin shirts. We have a red one, we've got a blue one, and we got a black one. Okay, we've got those 3 shirts. What do you think the chances are on any one day that all 11 of us would be wearing the same colored shirt? I'd say they're almost none. You can actually figure it out using probability. All right? The reason I'm telling you that is that's how people code. The chance of 2 people writing the exact same code in the exact same way are not very good. But the bottom line is, did your answer work, and does it work correctly for all cases? And if it does, that's much more important than how you got there. So 11 is C. Number 12, how many case labels would a switch require to be the equivalent of this? And that's kind of, it sounds like, wait a minute, it's 2, it's not, no. Case this, this would be the default that you see in gray there. So you'd only need 1. When it says case labels, it's case followed by something. So you'd say case 1, default. So there's only 1 case label. Again, not a great question, but number 12 is B. Number 13, the way that you make sure you don't keep falling through is you put in the break statement, which is A. So 13 is A. All right. 14. If the expression doesn't match any case and there is no default, it's like the switch wasn't even there. Does that make sense to everyone? Remember the example that we looked at before where we had case 1 freshman, 2 sophomore, etc.? If we didn't have a default there and you were a 5, so it wasn't a 1, 2, 3, or 4, it would skip everything. That's all they're saying. So 14 is C. 15. They're showing how you can do that with the ternary operator. So 15 is D. 16. which of the following is equivalent to this? And they're showing you, again, that's the not logic that we talked about at the end. Which of the following means this? I could easily write tests that most people would fail. I don't want to do that, but I could write my own test that just did a bunch of this manipulation, anding and oring and nodding, etc. Because you have to really sit and think about it before you do it. So 17 is B. $18. Which of the following? None of them. So D. 19. Which of the following does this? And the answer is B. And 20 is D, all of them. All right. Now, let's do this. Okay? Charles is going to come over here in about a half an hour. It is 9:56. At exactly 10:05, exactly, I will start doing that test review. All right? So 10:05 on my clock. So it's 9:56. So you have 9 minutes. A couple of you look like you're more asleep than awake. So you go out, throw water on your face, or do whatever you do to wake yourselves up. But we'll try to do that test review because when he comes in here at 10:30, we got to be done. So those of you who are slow typists, I'm going to bring this stuff up now. All right? So if you don't normally take a break, you might want to be, stay here for that. I just have to find it, that's all. That's not right. So when you come back, please bring up your actual test review page, the study guide for Chapter 4. Oh, and here you can get this. This was your.
Oh.
So hands-on tomorrow and then written test Friday?
Yes. And then what we'll probably do is the written test for this will be next Monday. All
So
right.
what are those exercises?
What exercise? For chapter what?
3.
3 and 4?
Whoa, 4, oh, I forget where we are.
Yeah, that's what makes it tough. I'll probably give you about a week and make it like next Wednesday. Regardless of what it says in the book. All right. Again, I don't want people to fall behind. Most everybody turn in something for chapter 1. Most everybody turn in something for chapter 2.
That was hard. Those were hard and there was a lot.
Yes.
That was
I'm still
crazy.
working on chapter 2.
That's why I said do what you can do. You know what I mean?
Well, now I'm
But,
kinda
but at least one person, and I'm not accusing anybody, but at least one person, what they did, for some of them, was they just created a new project. They did a console, and they created a new project, put no code in there at all.
I did that once, I think.
Okay. But that's not doing anything. There's not really much difference between doing that and doing nothing, in my opinion. So even if you just, if you've got 12 programs and you can only get 3 or 4 of them done, then turn in those 3 or 4.
Yeah, I'm still working on chapter 2. I'll get those in as soon as I can today.
Well, and you turned in most of chapter 1, but you didn't turn in the exercises.
Oh yeah, I got all chapter 1 done.
All right, then if you want to send me that one, you can.
reword that. There were like, I meant labs. So the one where it was like Chapter 2 labs, and then all the other exercises.
The labs are everything that's not what we're doing now. That's not the review. The review question we just went over, those 20 questions at the end of each chapter. Everything else is the labs.
Gotcha.